Welcome back. We have 3 more examples to do on this part of the section. This next example asks us to find the relative max and min of this function f of x squared over x squared plus 9, where we've been given a hint. The derivative is 18x over x squared plus 9 all squared. So we're going to start by looking for critical numbers. So search for critical numbers. We have f prime of x is equal to 0, and that means that 18x divided by x squared plus 9 all squared is equal to 0. We can cross multiply. 18x is equal to 0 times x squared plus 9 all squared, and that means 18x is equal to 0, and we get only one solution. We get x is equal to 0. Let's make sure it's in the domain. X is equal to 0, y is equal to f of 0, which is 0 squared divided by 0 squared plus 9, which is 0 over 9, which is 0, so yes, in domain. Okay, we also have to check f prime of x does not exist at where? So 18x over x squared plus 9 all squared does not exist if x squared plus 9 is equal to 0, because that would cause division by 0. That means x squared is equal to negative 9, and we already saw from a previous example this has no solution. So no additional critical numbers. Now we make a number line. Our number line goes from minus infinity to infinity. I'm going to cut the number line at the one point that we found at x is equal to 0. Now I have to choose 2 test values. So I'm going to pick, let's see. Well, I'm just gonna go simple. I'm gonna pick negative 3, and I'm gonna pick positive 3. Because if I pick those, it'll make my evaluation simpler. But you can pick anything. So f prime of negative 3, that's 18 times negative 3 divided by 9 plus 9 all squared. And as you can see, it doesn't matter what I have down there, it's going to be positive. I have something positive plus something positive, and then I'm squaring it, so that's going to be positive. I have plus times minus over plus, which is going to be negative. So f of x decreasing on the interval from minus infinity to 0. So I'll put a little down arrow there. F prime of positive 3, 18 times 3 over 9 plus 9 all squared. That's going to be positive times positive over positive, which is positive. So that means f of x is increasing the next region. Increasing on the interval from 0 to infinity. Then we can make a summary. There's a local min at 0, 0. I'll make that second 0 green to indicate where it came from. It came from where we got our y value by plugging the x value into the original function. Okay, next is an extremely important example. It's called test styled example for a reason. Suppose f of x is continuous and decreasing. So it's telling us where a function is decreasing, it's telling us where a function is increasing, and it wants to know the x coordinates of any local max and any local min. I'm going to make a number line. And the first information is that the function is decreasing on the interval from minus infinity to 12. So there's 12. I'm going to do a little down arrow for that. It's decreasing there. And it's increasing on the interval from 12 to 15. So increasing on the interval from 12 to 15. So put a little up arrow there. It's decreasing on the interval from 15 to 21. So it's decreasing like that. And then it's decreasing on the interval from 21 to 103. Oh, and there's another one. Oh. So decreasing in that region. And then, well, I got another color, I have green, increasing from 103 to infinity. Okay. So that's our arrow diagram of increasing and decreasing. Now determine the x coordinates of any local max and any local min. So here we go. It looks like there's a min. So local min at x equals 12. And there's another local min at x equals 103. And then there's a local max at x equals 15. Okay, so for a question like this, there's actually not much to do. You take the information in the paragraph, make a picture, an arrow diagram on it, and then interpret the arrow diagram. Where a function switches from decreasing to increasing, that's a minimum. Where it switches from increasing to decreasing, that's a maximum. And notice that at 21, it's switching from decreasing to decreasing. So not a max or a min. Okay, and the next question is also a question we don't have very much to do. It looks kind of scary, but it's not. Suppose f of x is continuous and you're given the following table about the function that's first derivative, and you're told that f prime of x is not equal to 0 or undefined at any other values of x than those indicated. Part A, determine the critical points of f of x. Part A, critical points occur when f prime of x equals 0 and or where f prime of x does not exist. And in the domain of f of x. So based on that, we can see that x equals -3, x equals 5, x equals 20, x equals 77, and x is equal to 100 are critical numbers. So the points are the x values comma the y values. So we have -3 comma -3, and then 5 comma 7, and then 20 comma -5, and then 77 comma -8, and then 100 comma -12 are critical points. Just pairing up the x values and the y values. Now part B, we need to make a number line. So a number line has to contain we only have to cut the number line at those particular x coordinates. So at -3, +5, +20, +77, and +100. So I'll make it a little bit smaller. Okay, now I have to check whether the derivative is positive or negative in each of those regions. So, oh, did I miss one? Ah, I missed one. Look, -50. Aha. Oh, -50. There's a 0 up there. I missed it. How'd that happen? So -50 comma 2. Gotta throw that in there. Whew, almost missed that. So -50, -3. There, okay. Now we have to check if the derivative is positive or negative in each of these regions. I'm going to indicate positive derivatives by increasing arrows and negative derivatives by decreasing arrows. So I see there's a negative derivative. Derivative is -9 up there, so I have a decreasing to the left of -50. And then it's decreasing at the test value of -25, so it's decreasing here. This is still decreasing. Then to the right, so between -3 and +5, we have increasing. So this is a positive derivative, so increasing. Then from 5 to 20, my test value would be 10, and it's decreasing there. So it's decreasing here. Then it's decreasing of the next test value at 40, between 20 and 77. And it's decreasing of the next one. And the last one is increasing. So this is a positive derivative. So increasing versus decreasing inferred from f prime of x being positive or negative inside each region. Okay, now we can do the interpretation step. There's a min -3, comma, -3. And another one at 100, comma, -12. And max at 5, comma, 7. That's it. There's no other places where the increasing, decreasing switches. It only switches at -3, and it switches again at 5, and it switches again at 100, and all the other things, even though they're critical numbers, they're not locations across which the sign of the first derivative changes from positive to negative.